Math 1314, Tyler Junior College, section 3.3, dividing polynomials, remainder and factor theorems. In the previous video, we kind of discussed a general way to factor a polynomial, but there were a couple of kinks that we needed to work out. One was locating a zero of the polynomial function prior to actually finding all the zeros. And the second was, if we have a factor already, which we can get from a zero thanks to the factor theorem, then how do we find the other factor? The short answer was do a division problem, which means we have to learn how to divide polynomials. So let's start with polynomial long division. Now, this is not the same polynomial as we were trying to find the zeros of in the previous video. That had a 4 here. I changed it to a 6 so I can make a point in this first example. So how do you do long division with polynomials? Well, first you need to know who is who. When you're doing a polynomial or any division problem, the expression that you're dividing into is called the dividend, and the expression you're dividing by is called the divisor. And as usual, like with the numerical long division problem, which we're going to work in a moment, when you set up a long division problem for polynomials, you write the divisor on the outside of what I call a division house. I can't find the technical name for the symbol. Somebody said it was called a vinculum, but that is incorrect. That's the official name of the bar you put over a repeating decimal. But the divisor goes on the outside, so x minus 1, and the dividend goes on the inside. So x to the third power plus 2x to the second power minus 7x plus 6. Now, how do you do polynomial long division? In short, the same way you do numerical long division, such as this problem. So in order to explain how to do this one, I'm going to do this one. And we're going to go back and forth between the two to point out that the steps you make are actually the same. You just have to think of them a little bit more abstractly when you're dividing polynomials. So let's start with the numerical long division problem. What's the first thing you ask yourself over here? The answer is, how many times does 12 go into 15? And the answer to that is only once. So you would write a 1 above the dividend. Over here you ask yourself the same question, except when you start a polynomial long division problem, you start by focusing on the leading terms. The leading term of the divisor is just x, and the leading term on the dividend is x to the third power. So the question you ask yourself at the outset, at least for this problem, is just like the question over there. How many times does x go into x to the third power? So same question, just with monomials. Now the answer to this might be a little unclear. You might think the answer is 3. That would be incorrect. Why? Because 3 times x is not x to the third power. Some people don't have a problem answering this, but if you have trouble answering it, here's a really easy way to do it. I'm just asking you a smaller division problem. How many times is this going to that? Well, set it up as a division problem in the form of a fraction. I want to divide x to the third power divided by x, and then start using exponent rules. In this case, the exponent rule says when you have like bases on top of each other, then you can subtract their exponents. Since the implied exponent in the denominator is 1, 3 minus 1 is 2. And so the answer to how many times does x go into x cubed is x squared times. As weird as that may sound. And then we write that above. Some people will write it above the leading term that they're focusing on. Some people will write it above the like term. So it doesn't really matter. I'm just going to write the x squared above the x squared. That makes sense to me. So the first move is the same. How many times does this go into that? How many times does this go into that? How many times does this go into that? The only trick is answering it. Might be easier if you stack it as a fraction and reduce it. All right, let's say we get past that move. What's the next question we ask over here? The answer is not what is 15 minus 12, because I get that a lot. The answer is what is 1 times 12? 1 times 12 is 12. I almost said 15. Well, that's the same move we do over here. So the second question we have to answer over here is what is, whatever the first term in the quotient is, the answer to the division problem, times the whole divisor, not just its leading term. So when it comes to multiplying, you multiply everything, not just the leading term. So this x squared is going to get distributed across the entire divisor, and the product is going to get written underneath the quotient. Well, this is easy. I just have to distribute x squared. I'll go ahead and write the work over here, but in practice, you don't want to have to go to the side to answer all these questions. You need to know what the questions are, but they should be simple enough most of the time that you can answer them in your head. If I distribute the x squared, I get x cubed minus x squared. So x squared times x minus 1 is x cubed minus x squared. So it's the exact same move as over there. Multiply the first term on the top times the divisor, write it underneath the dividend. Multiply the first number in the top times the divisor, write it underneath the dividend. So pretty easy. So let's go back to the numerical problem. What's the next step over here? Now it's time to subtract. 15 minus 12 is 3. So guess what the next move over here is? Subtract. But this is where most people will make their mistakes, if you make mistakes. The move is the subtraction move, but if I just stick a minus here, I'm going to miss it. Why? Because if I just stick a minus here, I am only subtracting the x cubed. I have to subtract the entire result down there, which means technically it needs to go in parentheses. But that raises another problem. I've got a negative in front of a parentheses. Well, that's not a problem. We know how to overcome it. We just have to distribute. So when it comes to subtraction, you're going to distribute a minus across the entire result down here. And the easiest way to do that is to remember that when you multiply by negative, it just changes the signs. So when it comes to subtraction, the easiest thing to do is to change each of these terms' signs and combine. And if we combine these, the x cubes cancel, and the leading term should always cancel at this point. This whole process was designed to make that happen. And when we combine the positive 2x squared and the now positive x squared, we get positive 3x squared. So how are we going to document this? We would ask, what is x cubed plus 2x squared minus, it was x cubed minus x squared before we changed its signs. But in a word, your next move is subtract, carefully by changing all the signs and then combining like terms. So be very careful there. All right, so subtraction is the next move. What's the next move after that? We just did 15 minus 12 is 3. What's our next move? Bring down the next digit in the divisor. In the dividend. So bring down this 3. And guess what the next move over here is? Bring down the next term in the dividend. So for this particular problem, the next question is not a question, it's just something to do. Bring down the next term. And at this point, you just repeat 1 through 4 until you finish. You'll know you'll finish after you, well, we'll see when we get there. In fact, let's go ahead and finish the numerical problem. 12 goes into 33 twice. 2 times 12 is 24. 33 minus 24 is 9. Bring down the 1. 12 will go into 9 7 times. It may take a little while to figure that one out, but it's 7 times. 7 times 12 is 84. Yes. 91 minus 84 is 7. We'll talk about what to do with the remainder in a moment. Let's finish this long division. Remember, when you ask yourself how many times does this go into this, you only focus on leading terms. So how many times does x go into positive 3x squared? Well, we can attack it the same way as before by setting up a fraction and reducing it. So to answer the question, how many times does x go into positive 3x squared, you can literally put positive 3x squared over an x and think about reducing that. Well, one of the x's would cancel, leaving me a positive 3x. Notice I'm keeping up with the pluses and minuses. So positive 3x is the next term in our quotient. And then after we figure out the next term up top, it's time to multiply. So now, multiply positive 3x times the entire divisor. That will distribute. And the product will get written under where we currently are. X squared times x is, I'm sorry, wrong term. Positive 3x times x is positive 3x squared. Positive 3x times negative 1 is negative 3x. And then it's time to subtract by changing the signs and combining. So the positive 3x squared becomes negative 3x squared, and the negative 3x becomes a positive 3x. The x squared terms cancel. Again, if the leading terms don't cancel when you're subtracting, something went wrong. And for the x terms, when we combine them, we get negative 4x. And let's bring down the plus 6. And do it one more time. How many times does x go into negative 4x? Again, you can just put negative 4x on top of x and think of reducing that. The x's cancel, we get negative 4. So the final term in our quotient will be negative 4. That's our next multiplier. By the way, I wouldn't erase and draw all these arrows. I'm just doing them for instructional purposes. Negative 4 times the entire divisor. Negative 4 times x is negative 4x. These match. They should at this juncture. And then negative 4 times negative 1 is positive 4. Change the signs. So the negative 4x becomes positive 4x, but the positive 4 becomes negative 4. Combine, the x terms cancel, positive 6 and negative 4 is positive 2. And we're done with the division because I have no more terms to bring down. So it's the same steps. How many times does this go into this? Write the result up top, multiply, subtract, bring down the next term, and then keep doing it. After you've brought down the final term, you only have to go through it one more time. Let's talk about the remainder. Over here, the remainder is 7, and there's actually 3 things we can do with it. We can put a decimal 0 and keep going, except that's not an option here. We could put R7, but that's a little bit, there's nothing wrong with it, but it's just not what we're going to do. Or we could say that there's still 7 out of 12 left. Put the 7, put the remainder on top of the divisor and literally add it on to the rest of the quotient. That's what we're going to do over here. If you have a remainder that's not 0, you write the remainder on top of the divisor, x minus 1, and literally add it on to the rest of the quotient. So the answer to the division problem is x squared plus 3x minus 4 plus 2 over x minus 1. If you recall, in the previous video, the 6 was a 4. If it were still a 4, then this would have been a remainder of 0. There would have been no remainder attached, and that would have been the other factor in that problem. In the next video, we'll look at a couple more, or maybe one more long division problem, because even though long division is convoluted already, it's got some issues.